In this question, we need to get the maximum of minimum of every window size. What does it mean? Here, suppose we have window size 2. So for window size 2, here the minimum would be 10, then minimum would be 20, minimum would be 30, minimum would be 10, minimum would be 10, minimum would be 30. And from these minimums, we need to get the maximum. So the maximum is 30. So this is for window size 2. And in our question, we need to return this maximum value for every window size. Just like we have calculated this for window size 2, we need to get this for window size 1, window size 2, window size 3, window size 4, window size 5, 6, 7, means up to n, that is 7. So what could be a naive approach? Means what could be the brute force approach is, for every window size we will get the minimum first and get the maximum out of it. Let's write the pseudocode for it. So how we are going to do it? We would be returning a vector of int answer, right? This would store the maximum of minimum of every window size, like for 1, 2, 3, for every window size. So its size should be n. Now we have a for loop for window size 1. Window size would be less than equal to n, window size plus plus, right? So how we would decide the window size? Like suppose for 2 we will have 2 pointers, first on 10, second on 20, then we'll slide it up 20 30, we'll slide it up 30 50, slide it up 50 10, 10 70, 70 30. Similarly for window size 3, 10 20 30, the 2 pointers 20 30 50, 30 50 10, 50 10 70, 10 70 50. That's how. So suppose we have window size 1 and the first pointer I pointer and I would be 0 and j would be window size -1. Like here for window size 1, the ith would be at 0 and jth would be at 0 as well. For window size 2, I would be at 0, j would be at 1. So window size -1. And while j is less than n, we will slide the window until j is less than n. So for index is equal to I, index less than equal to j, index plus plus, what we would do? We will take a minimum value first, int mini equal to int max. Now mini would be storing the minimum of mini and ARR of index, right? And the answer for window size -1 would store the maximum of answer of window size -1 and mini. because we need to get the maximum of minimum of those things, right? So this would be the pseudocode for our name approach. How will we calculate this thing in a single iteration? Let's observe something. Suppose here we have 10. So for maximum what window size, 10 would be the minimum value. Let's check. For this window size, could 10 be a minimum? Yes. For this window size, could 10 be a minimum? Yes. For this window size, can 10 be a minimum? Yes. For this window size, still 10 be a minimum, right? For this window size, 10 be a minimum? Yes. For this window size, 10 be a minimum. So this 10 could be minimum for window size up to 1 to n, right? Suppose we are having 30 here. Okay, 30. This 30 could be minimum for the window size 2. Could this be minimum for this window size? No. So for window size of 2, the minimum could be 30. Let's have 30 again here. Could it be a minimum for window size 2? Yes. Could it be minimum for window size 3? No. Okay. Here 20. Could it be a minimum for this window size? Yes. 20, 30, 20 would be minimum. Could it be a minimum for 3 size? Yes, it would be minimum. But for this 4, no, it would not be minimum. So for every element we can calculate its maximum window size, for which it would be a minimum value. And how it would help us to get our answer, you will get it in the next time. But let's get the maximum window size. How we are getting the maximum window size? Suppose we are here standing at 30 and we need 30 to be minimum. So the elements around it should be greater than or equal to this 30, right? So 50 is greater than 30, so we can have it in our window. 10 is not greater than 30, so we can not have it in our window. So we can go till here to the right, and 20 is not greater than 30, so we can go till here. So this would be the window size, right? And suppose for every position for every window size we are getting the maximum of minimum of that window size. Like here, for window size 1, 2, 3, 4, 5, 6, 7 window size we are getting the maximum values. Suppose let's have 10. 10 could be the minimum for window size this 2, 3, 4, 5, 6 and 7. So let's have their values 0 first. For window size 7, 10 would be minimum. So maximum of 10 and 0 would be 10. Now let's have 20. For what window size 20 would be minimum? Not this, this. So window size, for window size 3, this 20 could be minimum, because before it 10 is less than 20 and here 10 is less than 20. So for 3 window size, 20 is minimum. Window size 3, 20. Maximum of 0 and 20, 20. So this 30, for what window size it would be minimum. 30 and 50 for only size 2. So 30 would be minimum. 50, could it be minimum for? It would be minimum only for window size 1, right? So 50. Okay. 10, for it would be minimum for window size whole, right? So maximum of 10 and 10, 10. 70, is it minimum for only this window size, right? So 1, maximum of 70 and 50, 70, right? Now 30, 30 could be minimum for this window size only, right? For window size 2, it's already 30, so we don't need to update it. So now we have maximum values for all window size, but these are zeros. Suppose, let's just observe that 1, 2, 3, 9, 20, 30, 50, 10. Suppose this is minimum for 4 window size. Then would 10 be minimum for 3 window size? Yes. Would 10 be minimum for 2 window size? Yes. Would 10 be minimum for 1 window size? Yes. So we can just iterate through from back to start position. 10 is minimum for 7 window size, so it would be minimum for 6 window size. We can update it to 10. 5, 10 is minimum for 5 window size. We can update to 10. It is minimum for 5 window size, then it could be minimum for 4 window size, then 10. Can we update it because it's already 20? 20 is maximum, then 10, so don't need to worry. 30 is maximum, then 20, no need to worry. 30 is maximum, then 70, no need to worry. So what we got, our answer is 70, 30, 20, 10, 10, 10, 10 for every window size. And we can verify this answer just by, let's have one window size. For one window size, the maximum of them would be answer. So 70 would be for one window size. Let's have two window size. 20, no, for two window size we will be getting this 10, for this 20, for this 30, for this 10, for this 10, for this 30, maximum of 30, 30, right? For 3 window size, 3 window size minimum is 10, minimum is 20, minimum is 10, minimum is 10, minimum is 10. So maximum of it is 20, 20, this 20, this 20, it's right. For 4 window size, 4 window size minimum 10, 4 window size minimum 10, 4 window size minimum 10, 4 window size minimum 10. So 10, 10, 10, right? Similarly, for 5 window size minimum 10, 5 window size minimum 10, 5 window size minimum 10. So 10. Similarly, here we will have 10, 10. We can check that our optimized approach is getting correct answer, right? So let's code it up. Here it is the question, and n should be ARR.size, right? And for getting the window size, we would need the next smaller element and previous smaller element. So suppose we can have vector and previous of size n, next of size n. We would need a stack of vent st we will iterate through the array int n int I equal to 0, I less than n, I plus plus, and while not st dot empty and a double r of st dot top is greater than a double r of I, we would do st dot pop and index would be if st dot empty index would be -1, means previous smaller element would be at index -1, else it would be at index st dot top, and we would update previous of I should be at index and st dot push would be I. We would do the similar thing for getting the next smaller element. Before that we would need to empty the stack st dot, while not st dot empty st dot pop, we have emptied it. Let's calculate for the next smaller element. Then we, if nothing in the stack, the next smaller element would be at n, and we are calculating next st dot push I. That's how we have calculated the next element, but we would need to iterate from the back. So int I equal to n minus 1, I greater than equal to 0, I minus minus, right? So here we have written correct. Now we would need vector of int answer, which we are going to return, and we would iterate for int I plus 0, I less than n, I plus plus. We would iterate and find the window size for each element when that element is minimum. The window size int window size, it would be next of I minus previous of I minus of 1. This would be the window size, and for this window size we would write answer, right? So answer of window size minus 1 would be max of answer of window size minus 1 and a double r of I, right? So this is how we would set the maximum answer, but we need to iterate from the back, so that even if some answer is stored as 0, it would be corrected. So for int I is equal to n minus 2, I greater than equal to 0, I minus minus, and we would do answer of I would be maximum of answer of I and answer of I plus 1, right? This is at what we should do, and at last we need to return our answer. Let's check the code. Have we written it correct? a_r.size previous next, declared the stack, then we have calculated the previous and next smaller element, previous and next, then we have declared the answer should be for window size. For window size, we have calculated the answer in ARR of I. Answer of I should be maximum of answer I plus 1. It should be 0. And yeah, we are getting the correct answer. So let's submit it up. Yeah, it's correct. So thank you so much. Bye.